Bismillahirrahmanirrahim. I am Abid Rida Babil, your chemistry teacher for GSCH 101. Today we will learn the module number 5, that is thermochemistry. This module contains two parts. Part 1 contains first law of thermodynamics and the part 2 contains Hess's law. This is part 1. In this part 1 we will learn about the first law of thermodynamics. So let's begin our module. Thermochemistry, module number 5, chapter number 6. Therm means heat. This term here means heat, and we will learn about the change in heat during the chemical reaction, that is called thermochemistry. Study of energy or study of heat during a chemical reaction is called thermochemistry. In mechanical you call it thermodynamics. Same thing. Here we have some difference that we call it chemical reaction. In mechanical you call it work. We will study it in this module. So to do any work we need the energy. Not any work is not possible without the energy, and there are various types of energy. Here are the some examples of the energy, and the slide is clear. You have to understand, learn the definitions of different types of energy, but in this module we will learn about the heat energy only, although you must know the other energies also. But during the chemical reaction, mostly the heat energy is changed. Other energy is also there, maybe light, maybe some other energy also there, but here we are studying only the heat. So there is a common confusion between the heat and temperature. Heat and temperature are not same. Thermal energy and the temperature are not same thing. Heat is the energy. Heat is energy due to the kinetic motion of the molecule, and the unit of heat is calorie or joule, and the difference and the conversion unit of calorie and joule is given here. 1 calorie is equal to 4.184 joule. So this is the conversion factors that is important, and heat is measured by the calorimeter. This is calorimeter. This you will use in the experiment in the lab, experiment number 6 after the mid lab. So the difference between the heat and temperature: heat is energy and temperature is the measure of thermal energy, or you can say sensation of hotness and coldness, or you can say temperature gives the idea of direction of flow of heat from high temperature to the low temperature. The unit of heat are Celsius, Kelvin and absolute. When we need to learn how to convert Celsius into Kelvin, so plus 273 in Celsius will change into Kelvin, and the temperature is measured by the thermometer. So this calorimeter and the device to measure the heat, and thermometer is the device to measure the temperature. So difference between heat and temperature, different unit, different devices, different measurement, different calculation, and this we will study about the heat. So again come back to the thermochemistry, study of heat during the chemical reaction. To study any process we need a system. A system is the part of the universe, specific part of the universe under the study. Suppose a test tube, you take a test tube and you do the reaction, so test tube is your system. The remaining part of the system is called surrounding. Around the suppose this system here, if we take a boundary around it, then this will be called surrounding. Whole universe is surrounding, not only this area, whole universe is surrounding. So system can be small and big, System can be real, can be imaginary, But here we have to study three types of systems according to the energy and the mass exchange in the system. So number one is called open system. Open system is a system in which both mass can go inside and outside, and energy can also go inside and outside. System is open, like your test tube. You take a test tube, you put some chemical, the reaction will take place in the test tube. You can add more chemical, you can remove the chemical, and heat can be produced in the test tube, and you can give the heat to the test tube. So that is called open system. Here the mass and energy both can be exchanged. Very common thing. Another thing is closed system. Closed system, here in which the system is closed and we cannot change the mass, we can change only the heat. Heat can go inside and outside. The best example is tube light or the bulb. The mass of the bulb remains same no matter how long you use it, and the energy can go inside, electrical power go inside the bulb, and light comes out of the light, and heat also comes out from the bulb. So energy can be changed but mass cannot be changed. That is called closed system. So only energy is possible to exchange. In the isolated system, here number 3, not the heat, not the mass, nothing can be changed. System is closed also, and also thermostat. This is thermopore here. It insulated system, and energy cannot go out of the system. We suppose it actually. Energy cannot be stopped. Energy always flow. So this is an imaginary system. We suppose that yes, mass cannot be changed. It's okay. We already have this idea here in the bulb. But here the energy is also not possible to exchange. In reality, energy will flow after some time. For a time being, we can say yes, in the beginning, energy cannot flow. Like thermos. So the thermos, you keep the tea, it remains hot for some time, few hours. After some time, again the heat will be lost. So this is an imaginary system. It is not real. So 3 types of system: open system, here, closed system, and isolated system. 3 systems are here. Now we come to the types of reaction. 2 types of reactions are there. 2 types of process we call reaction. One is exothermic. Here exo means energy will go out. It gives off the heat. The reaction in which the heat is produced, it is called exothermic. So exo, actually this word come from exit, and you already know the exit means exit. So this is X. Exit means energy go out, and it will be represented by minus. This minus is very important. Minus means exothermic reaction, the type of reaction in which the heat is given out from system to the surrounding. So look here, the from system to the surrounding, energy will go out of the system. So it can be represented by chemical equation. You write a chemical equation, this hydrogen plus oxygen make water. The energy will be evolved, and energy is written on the right side of the equation, means energy will go out. Right side means right side is the product. Left side, this is called the reactant. This is called reactants, means you add here, and right side is called product, means it is produced, given out. So product is water and the energy. So similarly, another example here, this is the water gas. Water gas means this is steam. Water in the gaseous form means steam, and water in the liquid form, it is water, normal water. So steam condensed to liquid water means energy will go out. Energy will go out. So it is written on the right hand side. Another method of writing the chemical equation is that you write the chemical equation and you write delta H and you say the minus sign. This minus sign here means this is exothermic. This minus here, the delta H, it says minus here. So if your delta H is minus, it is exothermic. So methane gas, this is methane gas, CH4 burns in the presence of oxygen, gives carbon dioxide and water, and the energy minus means energy will come out. So 2 methods are there. Either the word energy is written on the right hand side means exothermic, or delta H is shown in the minus number, then it is called exothermic. 2 methods. Similarly, in the endothermic, endo means enter or inside, means energy is absorbed here, and energy will be supplied to the system from the surrounding. Means energy will go in the system from the surrounding, and the energy will be written here on the left side. These are reactants. So mercuric oxide chain to mercury and the oxygen is separated. So energy is required here. So this endothermic, without energy this reaction will be not possible, and energy will be written on the left side of the reaction. So again this energy is on the left side of the reaction. It means it is the reactants, means it is provided. Water is a solid. This S means solid. Solid means this is ice. So ice change to liquid means ice is melting. So energy will be absorbed. The other things here, this is solid to liquid, and here it's the same equation. This equation and this equation is same. This is solid water means ice change to liquid, but the energy is given in the form of kilojoule per mole, and it is given here in the plus form. So plus is not written here. I will write for you to make you understand. So this is endothermic, means delta H is in the plus form. So here this you see the delta H is in plus delta H means endothermic. So I hope you understand the exothermic and endothermic. We will mostly use the in terms of delta H minus means exothermic, and delta H plus means endothermic. Now same thing again in the graphical representation. So this is hydrogen and oxygen combine to form the water. So energy is released, energy is gone down, energy is released. So this graph here, this represents the energy increasing here, this graph, and the energies go down, means this is exothermic reaction, and energy is given off. Given off means given out to the surrounding, from the system to the surrounding. And here this reaction is just mercury plus oxygen change to mercuric oxide. So this mercuric oxide is decomposing, and this is the reactant, and this product is mercury and the oxygen pure. So energy is increased. This is endothermic reaction, and heat is absorbed also. This is here absorbed, and by the system, energy is absorbed by the system from the surrounding. So this is endothermic reaction, this is endothermic reaction, and this is exothermic reaction by graphical representation. So now we can start the first law of thermodynamics. I told you this thermodynamics. We are studying thermochemistry in this course, but the law is from thermodynamics. Thermodynamics first law states that energy can neither be created nor be destroyed, but it can change from one form to another form. This is very famous law, and you have studied it before. The same law can be represented by the mathematical equation that the energy of the system plus energy of the surrounding will remain same. Total will remain same, that is 0. The energy gained by the system is equal to energy lost by the surrounding, or energy gained by the surrounding will be equal to energy gained by the system, means vice versa. So total energy of the universe will remain same. So suppose we take a system here. This is a system, this is a gas, and this is a piston, and this gas is filled here in the cylinder, and we provide some heat. This is the heater. We give some heat to the system, so heat will go inside the system and the gas will expand. If the gas will expand, so some work will be done. So this work is called W here. This work is W, and this is the system, and this around the system, whole universe will be called surrounding. So system and surrounding. Any machine or any test tube in which you are doing reaction is called system, and remaining part of the universe will call the surrounding. So here is giving one example, this propane burning in the presence of oxygen producing carbon dioxide and water, and energy is going out. If the energy is going out, then it's called exothermic, and this is shown here in the diagram here. This is the heat, fire is there, so this is called exothermic, energy is coming out of the system. So same thing is here in chemical energy loss. This is the heat, exothermic here, this is loss, and this is the system, will be equal to the energy gained by the surrounding, and this is the surrounding. So the quantity of propane you burn, the energy will come out by the burning of the propane will go to the surrounding. The quantity of energy which is produced by the propane burning will be equal to the quantity absorbed by the surrounding. Both will remain same. So this is the first law of thermodynamics, and we have to learn some mathematical form of first law of thermodynamics. This is the mathematical form of first law of thermodynamics. Delta E means internal energy. E means this energy, this internal energy of the system. Suppose we take a system here again, and this is gas is inside in this cylinder. Some gas is filled in the system and it is closed by the piston. So this is called your system. The energy of this system will call internal energy of the system. Okay. And Q is the quantity. Q means this Q is quantity of heat exchange, maybe go in, maybe go out. And the W is the work. W means work done on the system or by the system. And this explanation of plus and minus is explained here in this case. Delta E can be plus and minus, and Q can be plus and minus, and work can be plus and minus. How? So if you see the W is minus, means work is done by the system. Work is done by the system. This I will explain you here. Suppose you heat this thing, and this is the heater. This is the heater, and you heat this thing, and the quantity of heat go inside. So if the quantity of heat go inside, then Q will be positive. This is positive Q, means heat goes from the surrounding to the system. Heat is absorbed. Heat is absorbed by the system from the surrounding. Thus, the heater is, this heater is in the surrounding. System is only the cylinder. So Q will be positive. Okay. And when the heat go inside, the internal energy delta E will be increased in the system. Delta E will increase in the system. So it will be also positive because it is coming from outside, from surrounding to system. So that is positive delta E. This one means internal energy of the system increase. Internal energy of the system increase. Now if you give more heat here, more heat goes inside, and then gas will expand, and the piston will go up, gas will expand, and some work will done by the system. This distance covered by the piston is called work done by the gas. So because work is done by the expansion of the gas, so work will be minus, this is minus W, because this gas expand by itself, expansion of the gas, and work is done by the gas, by the system, so W is minus. But suppose we are not giving the heat, but somebody comes from here, from outside, and holds the piston by his hand and give the energy, give the power by his hand, and press the piston and compress the gas. So who is doing the work? Work is coming from somebody. Somebody has come from outside and pressed this cylinder. So work is W, means work is done on the system. Somebody has done the work on the system, and the gas will contract. So if work is done from outside somebody, then it will be plus, and it will be called work done on the system. So gas will contract. And then if the energy, this delta E, is gone out, for example here, then it will be minus. So this is minus delta E. The internal energy of the system decreases. And minus Q means energy go out. So if this energy, we remove this heater and change this heater with some cooler here, or remove it, the energy will go out, and then Q will be minus. So minus Q will be there because energy is going out. So this minus Q here, it is here minus Q, and it means heat is minus Q. This is number 4 here. Heat is absorbed by the system. Okay. So this is the problem here now. I hope you understand all these 6 conditions here, and then we'll solve this problem. Here it says the work done when the gas is compressed. So somebody is doing the work from the outside. Compress means gas is pressed by some outside force. So we say work is equal to plus 462. 462 joule. This is 462 joule. This is compressed, so it will be plus. And then we say here 128 is the heat transfer from to the surrounding. Is going out. To the surrounding means going out, from system to surrounding. So this is quantity of heat going out of the system minus 128 joule. So what will be our formula? The calculation here, this is asking to calculate the energy of the system. So delta E is equal to, work is positive, so we say plus work, and quantity of heat is minus, so we say the minus Q. So one work is plus 462 minus 128 is equal to 334 joule. This is the internal energy plus 5. We don't write plus here for you. I am just teaching you this plus means heat is internal energy of the system increases here. Okay. Now here in this case here he says the gas expand. When you see the word expand means work is done. PV, pressure volume, work is done. So work is minus W is equal to minus how much? 279. And at the same time it absorbs 216 joule of heat from the surrounding. From the surrounding means heat is coming inside. So Q will be positive 216 joule. This work is also joule. Okay, so we solve this. Question is delta E, calculate the energy of the system. This is the energy of system. So delta E is equal to Q. This time it will be Q is positive and work is minus. So Q is 216 quantity of heat minus the work done by the system by expansion. So 279. Sorry, this is 279 is equal to minus 63. Answer is already given here, minus 63 joule. So this is very simple thing, just you have to take care of plus and minus, and this is all table is given here. This 6 things you have to learn, that when the delta E will be plus and minus, Q will be plus and minus, and work be plus and minus, and this is just a terminology which you have to understand to solve this problem. Okay.